Okay, so for the reciprocal functions, we graph the reciprocal first, like the points of the reciprocal. So in this case, we're going to graph the points for sine, because it's a cosecant graph for number 11. The period is 2 pi over pi, which is 2, and the amplitude, or not the amplitude, but the a value is 2. So if you look at the x-axis, I counted the fourth tick mark, 1, 2, 3, 4, that's a 2, half of that is 1, half of 1 is a half, and then times 3 gives you 3 halves. So every tick mark is up by a half. So here is 2, 5 halves, 3, 7 halves. Okay? So I'm going to draw the 5 points of sine. So beginning is 0, middle, and end. Maximum for sine is 1/4 of the way, and minimum is 3/4 of the way. And then the same, I'll just continue the same pattern. So over here at 5 halves is going to be at 2, at 3 it's 0, at 7 halves it's -2, and then at -1/2 is -2, and at -1 it's back to 0. So every time the graph, the function is a 0, that's where you draw the asymptotes. So there's one right here, one on the y-axis, one on the 1, one on the 2, I know they're getting messier and messier, one on the 3, and then now you draw the u's. Okay, the actual cosecant graph. The actual cosecant graph is now going to be on the, all this yellow stuff is just there to help you. The actual cosecant graph starts here. So here, down, the maximum goes up, the minimum goes down, maximum goes up, and minimum, you always go towards the asymptote, so it goes down like that. Okay, so if it's a minimum button point, it goes down. If it's a maximum point, it goes up, and that's it. Okay, for number 12, we have a secant graph, so that means the reciprocal is cosine. So you think of it in terms of cosine. The a value is 5 with a reflection. Period is 2 pi over 2, which is pi, and then it's a vertical translation of 5 units up. So I'm going to go ahead and again, notice the x-axis. Counted 1, 2, 3, 4, and there's your pi, the period, half of that, and half of that. And I multiply this by 3 to get 3/4, and then you know that every tick mark is a fourth. So after this one, this is 4/4, 5/4, 6/4, 7/4. So 5 units up. So I'm going to have the midline right here, and then there's no phase shift on this one. Okay, so then it's going to be cosine. So that one has zeros at 1/4, 3/4. So right here and here. Maximum is usually beginning and end, but this has a reflection, so it's going to go here and here. Minimum is usually a minimum, the middle, so the maximum is now in the middle. So right here. So I'm going to go ahead, oh, I forgot to use the yellow, that's okay. The next 0 would be 5 pi over 4. The next 0 would be 7 pi over 4. And then the other 0 would be negative pi over 4. Okay, and then we have at 3 pi over 2, we have a maximum point. And then we can't see the next one, the 2 pi. It's off the screen. Okay, so wherever you see the zeros, that's where you draw the asymptote, so right here. And by zeros, that means the midline, where the midline is located, the points that go through that. And right here. Okay, so now wherever you see a minimum point, that's where you draw the U going down. Wherever you see a maximum point, that's where you draw the U going up. And then at pi, down. At 3 pi over 2, oh, I forgot that asymptote right there. Right there. So from here it goes up. Okay, there you have 2 periods. Alright, for number 13, it's a tangent graph, so the A value is 2. Remember, it's not an amplitude, it's just, it's the A value. It tells you the vertical stretch or compression of the graph. Period is pi, because it's pi over 1. B is 1 in this case. And phase shift is pi to the left. So it's going to move a complete, it's going to complete move 5 units, pi units to the left. Okay, so I'm going to draw, originally I'm going to make it like, normally the asymptotes would go here and here, okay? Half of the period on the left, half of the period on the right. But now there's a phase shift of pi to the left, so that means 4 tick marks to the left. So if you think about it, this one is going to go 1, 2, 3, 4. It's going to land in the same exact spot where I have this one. So it's not going to show any change at all, because it's just going to like go over itself. See, 1, 2, 3, 4, exactly where it started. So it's not going to show any change. So I'm just going to go ahead and draw the asymptotes here, because that's where that one would go. And the one from the right would end up right here. So it's going to look like if there's no phase shift at all. And that's okay. That's how this one turned out to be. Okay, so the what do you call it? The 0 is in the middle. This one does not have a reflection, so the regular tangent has a positive A value on 3/4 of the way, so right here, and a negative value for A at 1/4 of the way. So that's the graph. Okay, I can graph a piece on the right and a piece on the left to make up 2 periods. So at pi, I draw the other 0. And this, from pi over 2 to pi, that's going to be the left side of the period, so that's going to be a point down here. Okay, and then from at negative pi is the other 0. So from negative pi to negative pi over 2, that's the right side of the period. So that's going to give me the positive A value up here. And there it is. Okay, for 14, I keep wanting to say 15. For 14, another tangent graph. The A value is 0.3. The period is pi over 4, which becomes 4. And phase shift, when you set the argument equal to 0, when you set this equal to 0 and you solve for x, you get 1 to the left. You get negative 1. Okay, so normally the amplitudes would go here at negative 2 and at positive 2, but because it's moving to the left 1 unit, it moves, the left one goes to the negative 3, and the one on 2 goes to positive 1. So everything gets moved to the left 1 unit. And then the next one would be at 5. So from 1 to 5. So let me just go ahead and draw it right now. Right there. Okay. There's no vertical translation, so the period, the middle becomes, let me just go ahead and change the color. From negative 3 to 1, the middle went from 0, 0 to negative 1, 0. Right, oops. That's erasing right there. And then the next one would be at 3. Okay. It's a tangent with no reflection, so that means that 3/4 of the way goes up, positive A. So it's approximately right here. And the other one would be right here, right on the negative 2. Over here on the second period, on 4 it would be at 0.3. And at 2 it would be at negative 0.3. And that's all you need. Here's the first period, here's the second period. Okay, for 15, the A value is 4, so there's a vertical stretch. The period is pi over 1, so it's pi. So if you see here, I did 1, 2, 3, 4, that's pi. Half of that is pi over 2, half of that is pi over 4. So every tick mark is a fourth of a pi, so 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. The vertical axis, I just labeled every 2, or every grid mark is 1. So I've got 2, 4, and then on the bottom it's same thing, -2, -4. For cotangent, you draw the asymptotes at 0 and the end of the period, so that would be 0 and pi. So right here, that would be for one period, here for the other. Okay, and then at 2 pi. There's no vertical translation, so then the 0 would be at pi over 2 and 3 pi over 2. For cotangent, the positive a is at 1/4 of the way, and 3/4 is the negative a. So here and here, and then 5 pi over 4 is positive a, and 7 pi over 4 is negative a. And that's it. Alright, for 16, the a value is 2, so there's a vertical stretch by a factor of 2. The period is pi over 2, and phase shift, when you set the argument equal to 0, you get pi over 2 to the left, or negative pi over 2. So the period, the asymptote would go here and here, but since we're moving pi over 2 to the left, again, just like in the tangent one that we did a couple problems ago, when you move this over 1, 2, 3, 4, because that's what pi over 2 is, 4 tick marks, 1, 2, 3, 4, you land in the first one. So it's not going to show any different. Like, it's not going to show that it moved. Okay? I ran out of room to draw the other one on the left, so I'll just do half of the period on the left and half on the right of the cotangent. So let's go ahead and graph it. The asymptote would go here and here, and then the 0 would be in the middle. For cotangent, there's no reflection on this one, so the pi over 8 would be positive 2. The negative 8 would be, the 3 pi over 8 would be negative 2. Here and here. And then the next 0 on the left would be negative pi over 4. So negative pi over 8 would be to the bottom. And then on 6 pi over 8 or 3 pi over 4, I have another 0. And then 5 pi over 8 would be a positive 2. Like that. And there's 2 periods right there. For number 17, the period is 2 units. And how do I know that? Because that's the distance between the two asymptotes. Between any two asymptotes here. So then from there, I did pi over b equals 2, and so I solved for b, and I got b equals pi over 2. Phase shift, it moved one. You could say 1 to the left, 1 to the right. I just chose 1 to the right. And then the a value is 1/2, and with a reflection. Okay, 1/2 with the reflection. So I'm ready to write the equation. So y equals negative 1/2 tangent, and then the b is pi over 2. Since it's moving to the right, I'm going to put -1. So this one's perfectly acceptable. You could distribute the pi over 2 and write y equals negative 1/2 tangent, parentheses, pi over 2x minus pi over 2. And that one's okay too. Alright, so for 18 to 20, here are the the calculator keystrokes. Make sure you're in radian mode for all of them. Okay, and you get those answers. For 21, tangent and arctangent are inverses of each other, and 45 is a real number, so the answer is 45. For 22, you evaluate the sine of 7 pi. Sine of 7 pi is 0, and then you do the arc sine of 0, which is also 0. Now this 0 right here is a ratio. This 0 right here is the angle 0. Okay, so although they're the same number, they mean two different things. Okay?